Alright, so first question here, solve for x by completing the square. Right, so completing the square, we first need to make sure the coefficients of x squared is a positive one. Right, so if you got your ax squared plus bx plus c equals to 0, we need to first make sure that the coefficient of x squared is a positive 1, and then we can follow the process of completing the square. Right, so we notice it is already a positive 1. If it was not a positive 1, what we can do is we can divide on both sides of the equation. If it is not an equation but an expression, then you will take out a common factor. Alright, so the coefficient of x squared here is a positive 1. So what do? We copy down ax squared plus bx, so that will be x squared plus 2x. Then what do we do after this here? We got our equals to p on the right hand side there, our constant. What we're going to do is we will add half the coefficients. So we're going to add half the coefficient of x. So that's going to half the coefficient of x squared. Okay, on both sides. So we're adding half the coefficient of x all squared. So what is the coefficient of x?
2.
Now this is not, we don't describe this as x, this is x squared. So we are looking at x, the coefficient of x is 2. So half the coefficient of x, that will be half of 2. Or the coefficient of x divided by 2, it's the same thing. Alright, so that will be half the coefficient of x. So let's see what happens here. So now we got x squared plus 2x, 2 over 2, that will be 1 all squared, and then we got p plus 1 all squared. Right, so now on the left hand side of this equation, what do we have here? We have a trinomial which is of the form a plus b all squared. This is squaring a binomial. So a plus b all squared is the same as a squared plus 2ab plus b squared. Or if the coefficient of x was a negative then you would have a minus b all squared, which will be a squared minus 2ab plus b squared. You know, the first term and the last term are always positive. So in a case like this, what do we have? We have a squared plus 2ab plus b squared. So what are we doing? We are going to factorize. A squared plus 2ab plus b squared will always be a plus b all squared. If it is a negative sign, it will be a minus b all squared. So there's your square there, we're going to factorize. There's my square there, you can see that in one step you can do this here. So what is your a and what is your b? So your a here will be x, and that's a positive there. Your b here is a positive 1, you can see that. So that's x plus 1 all squared. If you have to go and multiply this whole thing out, you can see it will be x squared plus 2 times x times 1 is 2x, and then plus 1 squared. There's your 1 squared. That is completing the square. It will always be like this. Alright, so that is equal to p plus 1 squared. 1 squared is just 1. Alright, so now we need to solve for x. We have the square there. We need to get rid of that square. How do we do that? We will find the square root of both sides. So the square root of both sides here . Now, when you are finding the square root, you need to consider the two possibilities there. Because this is a square, a negative squared is positive, and a positive squared will also be positive. So therefore, we put down both signs here, plus or minus. You follow? So now, the square root and the square from your exponent laws, you know if these two numbers are the same, they will cancel, but by using your exponent law. So let's see what happens here. You got plus or minus the square root of p plus 1, and you're almost done now. You're solving for x, you need to keep x alone on one side. So x is equal to minus 1 plus or minus the square root of p plus 1. There's nothing more we can do because we do not know the value of p here. And if we know the value of p, then we can work out the solutions. That was completing the square. Let's deal with some of these graph questions.
Minus 1.
Right, so
Same thing.
No.
first graph question, let's deal with it. Alright, so here, all you see is an equation. When you see the equation, you need to recognize what type of equation it is. You need to remember the standard form here. So here we got a plus sign separating your y squared and x squared. Okay, so maybe it's a circle. Or what is the other graph that you did?
Ellipse.
It's an ellipse. Okay, so your ellipse, you need to be familiar with the equation of the ellipse. What is the equation of the ellipse? It's x squared over a squared plus y squared over b squared is equal to 1. Okay. Now, you can see there's a plus sign separating the two terms. So now, what you can do is, you can go and try and rewrite this whole equation in the form x squared over a squared plus y squared over b squared is equal to 1. We do not have to do that, because what do we need to work out here? We need to work out, how does this ellipse look? Right, we need to work out our a and minus a, b and minus b. Right, x-intercepts and the y-intercepts. So, you could get it into standard form, or you could just work it out. Let's just work it out for now. If I want to work out the x-intercepts here, how do I work out the x-intercepts of any graph?
Make y 0.
That is where y is equal to 0, so we will let y equal to 0 here. So therefore I got 400 is equal to 16 times my y squared there, but we know that y is
0.
0, so that's 0 squared plus 25x squared. So now we got 400 is equal to
0.
0 plus 25x squared. So now we got 400 divided by 25 is equal to x squared. 400 divided by 25? 16. That will be 16. So we got x squared is equal to 16. Alright. So therefore, the square root of x squared is equal to plus or minus the square root of 16. Remember, when you got the x squared, you need to consider two possibilities there. So x is equal to plus or minus, that will be 4. So we know here, that will be a 4 and a minus 4. Simple thing to do. Let's work out the y-intercepts. Alright, for your y-intercepts, let x equal to 0. Go back to the original equation. So we got 400 is equal to 16 y squared plus 25 times 0 squared there. So 400 is equal to 16 y squared. So therefore 400 divided by 16 is equal to y squared, which is 25. You'll remember that from 400 divided by 25 is 16, so therefore 400 divided by 16 will be 25. Alright, so y squared is equal to 25. We need to work out the values of y. So the square root of y squared is equal to plus or minus the square root of 25. So therefore y is equal to plus or minus 5. Okay. So there's our x-intercepts. Here is the y-intercepts. Right, so that is one way of doing it. The other way, we got 400 is equal to 16 y squared plus 25x squared. Now, you could always rearrange this equation into your standard form. X squared over a squared plus y squared over b squared is equal to 1. So the constant is, what is your constant here? 1. So if I wanted to get 1 as a constant, what must I divide 400 by? By 400. So I could divide 400 by 400. Whatever I do on the left hand side, I will have to do on the right hand side. So that will be divided by 400 divided by 400. Okay, this might be an easier option. So what will happen here? 400 divided by 400, that will be 1. Then you got 16 divided by 400 there, which we just worked out. 16 divided by 400, that will be y squared over 25 there plus 25 divided by 400, that will be x squared over 16. Okay, I think this is much faster than working out x-intercepts and y-intercepts. Can you see that? So let me just rewrite it in order here. Okay. So we got x squared over a squared, so that will be, what is your a? That will be 4 squared plus y squared all over 5 squared is equal to 1. There's it in standard form now. So you know your a won't just be 4, it's going to be plus 4, minus 4, and this will be plus 5, minus 5. Let's sketch the graph. Right, so what is it here? Let's see, 4 minus 4, 5 minus 5. X-intercepts here, that is 4 minus 4, and that is 5 minus 5. Now, in M3, we must label the graph fully. That means x-intercepts, y-intercepts. This is the origin, which is 0, 0. Write down the equation of the graph. So there's it here. We must show what is the equation of the graph, and you need to write down the name of the graph. Okay, you're going to get 1 mark for the name of the graph, which is ellipse. Alright, so those are two different techniques here. You can see that. One, rearranging your equation in standard form. The other one, just working out x-intercepts and y-intercepts. What a question. Right, nothing too difficult here compared to the graphs that we were dealing with last time. Okay, let's deal with the next one. Any questions so far? You can't get this one wrong. Right, so the next one. X, y is equal to negative x. So here we got x multiplied by y. Okay. So when you have x multiplied by y is equal to a constant here, k, which is a constant. You could write it as y is equal to k over x. This is called a hyperbola. Okay. This hyperbola is a discontinuous graph. And it's not just one curve where you can just draw it without removing your pen from the page. This curve here, you can draw it with one time. Okay, you do not have to remove your pen or pencil from the page. But here, the hyperbola, there's two arms here. The two arms will be in two different quadrants. So here you've got asymptotes. The asymptotes here, if you look at this equation, y is equal to k over x. This is a fraction. Okay, and x is in the denominator. So you know that you cannot divide by what number? You can't divide by 0. Okay, so your asymptotes here, x is equal to 0. Or if I have to go back to the original and make x the subject of the formula, x is equal to k over y. So now I also cannot substitute y for 0 for y. So therefore your asymptotes here, y is also equal to 0. The graph must not touch these two lines here. Okay. Now, there's two possibilities. This one is easy in N3 because the center here, or the asymptotes, are at the origin, compared to the grade 12 questions where asymptotes can be anywhere else. I think some of you all did ask, you all came with some grade 12 questions with the hyperbola. Okay, so we got two possibilities here. So what will happen if this number is positive? Okay, so if that number k positive means anything greater than 0, then the hyperbola will be in which two quadrants? It will be in the first quadrant and the third quadrant. So you'll have your hyperbola there and there. You can see the curve must not touch the asymptote. This is y, this is x equal to 0, and this one is y equal to 0. What happens if k is less than 0? If k is negative, then your hyperbola will be in the second quadrant and the fourth quadrant. So this is a theory that we need to know. So what do we have here? We have x times y is equal to minus x. So let's compare. Is minus 8 greater than 0 or is minus 8 less than 0? Less than 0, so therefore second and fourth quadrant. Now, we need a few values here to get the shape of the curve. We need to know how is the curve, where is it turning, or the actual coordinates here. So to get a few coordinates, we draw a table. It's not the same as x-intercept, y-intercept. There is no x-intercept and y-intercept. It's not touching the x-axis. So let's use a table. We got x and then we have y is equal to minus 8 over x. Let's get a few points. Okay, let's use like minus 1. Let's go, let's go for minus 8. Something that will not give us any fractions. So if I put x is equal to minus 8, I will get a nice answer there, a whole number, an integer. Okay, let's go minus 8, minus 4, maybe minus 2. And then on the positive side, let's go 2, 4, and 8. You can choose any values you want to, as long as it satisfies the equation. If you substitute if you put x is equal to minus 8, then you need to work out when x is equal to minus 8, y is equal to minus 8 divided by minus 8, which is a positive 1. When x is equal to minus 4, minus 8 divided by minus 4, that will be
2.
a positive 2 there. Then when x is equal to minus 2, minus 8 divided by minus 2, that will be
4.
4. And then it will be the same, almost the same results, just that the signs will be different. When x is equal to a positive 2, minus 8 divided by positive 2 is minus 4, and then 4 will be minus 2, and then 8 will be minus 1. So you should have an idea of the shape of the graph, the coordinates. Right, so we know it's in the second quadrant and the fourth quadrant. Now, I'm just going to do a rough sketch here. Okay, I'm not going to start measuring in terms of centimeters and all that. But at least you are showing the coordinates. Right, you can show at least 1 or 2 coordinates. You don't have to show everything on the graph. Okay, but you need to show at least 1 coordinate. Right, so let's choose a coordinate. What do we want to show on the graph? When x is equal to 2, let's make 2 around here. When x is equal to 2, let's put 2 there. What is y equal to? Minus 4. That is 2 minus 4. Let's go on the opposite side. When x is equal to minus 2, let's put minus 2 around here. What is y equal to? 4. So that is minus 2 is to 4. You do not have to choose 2. You can choose any value you want to, but you can't put x is equal to minus 8 and write down 4 here. That then you will lose a mark because it's not making sense. It does not satisfy the equation. Alright, so we sketch the graph. Don't forget, you need to label, okay, there's the equation of the graph. You are showing the equation of the graph, and then you name the graph. Okay, what is the name of this graph? This is called hyperbola.
I'm closing it. I'm closing it.
So what graph do we have here? This is a cubic graph. You got y is equal to ax cubed. You see the power 3, it is a cubic graph. Alright, so now here we need to sketch the graph, show everything, label the graph. So what can we find here first? What do you want to, it's up to you what you want to find. Let's find the x-intercepts. Right, for x-intercepts, what do?
Make y equal to...
We let y equal to 0. So now, let me just put x cubed minus 9x on the left. Let's put the 0 on the right. Normally, with a cubic graph, we normally use the factor theorem. We substitute a value for x. We will find a factor. Then we will use that factor. We can use synthetic division or long division. Okay. It depends on the question. But now, do we need to go and use the factor theorem? No. Why? We need to factorize. Okay. So, what do we notice? X is common. So we take out a common factor. So if I take out x, what am I left with?
X squared.
That will be x squared minus 9 equals to 0. So now here we got our quadratic. Okay. What do we call this here? With the minus sign, and there's a square there, and 9 is also a perfect square. This is the difference of two squares. Okay. So that will be x minus 3, x plus 3. Now it's fully factorized. Can you see that? So now we got x is equal to 0 or x minus 3 is equal to 0 or x plus 3 is equal to 0. So here we already have one x-intercept. Remember, you do not divide by x. If you divide it by x, then you will not get x equal to 0. You lose one of the roots. So here x is equal to 3, or x is equal to negative 3. Those are the x-intercepts. What about y-intercepts? Y-intercepts, you let x equal to 0. You can see if I put 0 there, 0 there, y is equal to 0. Okay. Now, what else do we need to find here? Turning points. Okay. Okay, so we're dealing with calculus now. So you need to know your theory. What do you know? Well, what's happening at the turning points? Oh, we call it stationary points. The gradient of the tangent. If you draw a tangent, the gradient of that tangent will be what? 0. Okay. So to get the gradient in calculus, you find the first derivative. So that's dy dx, and you make it equal to 0. Right, so what do we have here? We got y is equal to x cubed minus 9x. So your first derivative, you'll all remember how to find the derivative. Right, so if you got y is equal to k x to the power n, when we differentiate dy over dx, that will be, you take the coefficient, multiply it by the exponent there, so that will be k times n. You copy down your base, which is x, take your exponent, and subtract 1. That is the rule that you are dealing with in N3 only, and in grade 12. Next semester, you'll be dealing with the derivatives of sine, cos, almost everything. As you come up to N5, N6, or maybe you're going to go to do Maths 1 in DUT or MUT or whichever university, then everything becomes calculus. But trigonometry is still involved in a big way. Okay, your factorization, you cannot forget anything. So make sure you know the basic rules now. Right, so the derivative here of x cubed, the coefficient here is just a positive 1. So we know k is 1, n is 3, so k times n, 1 times 3. I'm not going to write down every single step. At this stage, you should be able to do it mentally. 1 times 3, that will be 3x. All you do is subtract 1 from the exponent, that will be 3x squared. The derivative of minus 9x, that will be just minus 9. That is just a quick method of doing it. Okay. Remember, what was your exponent here?
1.
It was a 1. Okay. If you are wondering why are we not using this ruling, that is just a quick method. Let me just show you quickly. Y is equal to minus 9x to the power 1. If you want to use the formula, then the derivative here is going to be minus 9 times 1 x to the power 1 minus 1, which will become minus 9 times 1 is minus 9, and then we got x. 1 minus 1 is 0, and we know that x to the power 0 is 1. X must not equal to 0. Okay, any base to the power 0 is 1, except 0 to the power 0, that is not 1. That doesn't make any sense. Right, so 3x squared minus 9, what do we do? That is our derivative. So all we do is we substitute here. So 3x squared minus 9, we make it equal to 0. Solve for x, what can we do? If you want, it's up to you how you want to do. You can divide by 3 or transpose first. But let's transpose there. So 3x squared is equal to 9. So x squared is equal to 9 divided by 3 there, which is 3. Now you know that this is an x squared. So there are two possibilities, one negative, one positive. So the square root of x squared is equal to plus or minus the square root of 3. Okay. So x is equal to the square root of 3, or x is equal to minus the square root of 3. What did we just find now? These are the x values of the turning points. Now, we need the y values. If we have x, how can we find y? All we do is we substitute into the original equation. Not the equation that you divided by or did anything else. Always go back to the original. Alright, so let's substitute into the original. Let's call it f of x is equal to x cubed minus 9x. Okay, different notation. That is y. This is f of x. So now, why am I writing it like this? Because I am now substituting a value for x here. So f of square root 3. F of square root 3, that will be square root 3 to the power 3 minus 9 times square root 3. Square root 3 to the power 3 means square root 3 times square root 3 times square root 3. Square root 3 times square root 3 is what? 3 times root 3. So that will be 3 root 3 minus 9 root 3. These are like terms here. Can you say that?
Yes.
So 3 root 3 minus 9 root 3, that will be minus 6 root 3. Alright, so the other one, f of minus root 3. We're going back to the original equation, substituting, so that will be minus root 3 to the power 3 minus 9 times minus root 3. Minus root 3 to the power 3 means minus root 3 times minus root 3 times minus root 3. 3 negatives, definitely that is a negative. Negative times negative times negative is a negative. Square root 3 times square root 3 is 3 times the square root 3 will be 3 root 3 again. Here negative times negative, that will be a positive 9 root 3. These are like terms, so we got minus 3 root 3 plus 9 root 3, that will be 6 root 3. They did not, okay, here in M3 you don't have to find the point of inflection. So let's just stop there. Let's get the graph.